Hello everyone. My friend Chris would like to know just how much heat transfers up through these early monitor top glass fused electrical terminals that GE developed. They had patent on them and nobody else was able to have the glass evidently. You've got in this case on this DR1, a 2-inch long tube that's 1/2 inch outside diameter with about an 1/8 inch conductor up through it, and glass, molten glass or powder put in there or something and melted. On the inside you've normally got this copper sleeve on these that solders here. It's got the wire crimped in, it looks like, real tight in the center rather than soldered in, that led up to the windings. I've got it upside down because I could stand it that way easy. So normally you'd have this to dissipate heat, you'd have the wire to conduct heat away. So in a way our test isn't accurate, but in the real world the terminal would stay cooler from this conducting heat away. But we'll see what happens. First off, I've got a 25 watt soldering iron set up here. Let's see. And I let my phone go to sleep. I was going to do a stopwatch for us too here. Okay, so we're getting ready to try and heat this terminal up. My garage is fairly cold, so we're starting at 57 there. It wouldn't be insulated normally either, so I didn't do anything but put that bead probe on there with a tie wrap. Normally you'd want to use more than 25 watts and get it hot quick, but so far with a low watt iron heater we've gone quite a ways here and only raised the temperature at the other end a little bit. Of course, I don't have a solder connection between these two either to help conduct the heat. Not really putting that much heat up through there so far. I'm sure it would have went up a little more if I had solder between the two conducting the heat. But we've been over 2 minutes and not even gone up 10 degrees on the other end. Okay. Alright, so we got the brand new Weller. It's 100 watt on low and 140 on high. I'm going to go ahead and try and put it on high here if I can keep the trigger there. And we're going to see what it does. We're starting out 4 degrees hotter. Okay, what little bit of solder's there is already melting. So this end is getting pretty hot. I don't have much of a solder connection between the two, but it's melted at this end, the bottom. And we've only gone up 4 degrees at the top. I'll go ahead and add a little. Don't really want to, but I'm going to add just a little more. By now you normally would have had things soldered over with. It's been a minute and a half. I've gone up 8 degrees on top, 9 now. And normally you would have these on the other end conducting heat away, plus wire hooked to it, going up to the windings. So now we're going up to 71. So a 10 degrees rise so far. Looks like most heat gets dissipated out through the glass. These terminals, by the way, they're about 2 inches long, 1/2 inch diameter, about an 1/8 inch conductor going through. I didn't measure it, but I think it's 1/8 inch. Melted glass in between to fuse it. Those are the reason why so many other units had rubber terminals, because GE had the patent on the glass ones.